Hi everyone. Today we're going to look at fingerprinting. So the fingerprint is perhaps the most widely recognized symbol of personal identity. Its use in this matter is widespread, particularly in such fields as security. For example, we have fingerprint scanners to open doors, fingerprint scanners to log into computers, fingerprint scanners to open safes, fingerprint scanners to access your car. I have a fingerprint scanner on my cell phone right here that I use to log into my bank account when I'm accessing my bank remotely. It's really quite widespread. The fingerprint also has a great deal of symbolic resonance. For example, if we take a look at this disturbing painting, we might look at the masterful control of light and shadow in this painting and say, this painting has Caravaggio's fingerprints all over it, meaning it is clear that it was he who painted this. I thought this painting would be appropriate for a forensic science and criminology course. So what are we going to talk about in this video? In this video, we're going to be looking at the anatomical origins of fingerprints and how they're made. We're going to talk about the uniqueness of fingerprints. We'll look at a brief history of fingerprints in criminology, when did this start being used, and so forth. We'll focus on how to analyze and compare fingerprints, and then we'll briefly discuss the limitations of fingerprints as evidence. So our first question is, what are fingerprints? Where do they come from? And what I have here is a close-up image of the friction ridges on the surface of a finger. And you can see these raised areas on the surface of the finger, and you can see the depressed areas in between them. And so this is what your fingertips would look like if you were able to magnify them, and perhaps you'd like to take a glimpse at your fingertips right now, and you can see those fingerprint ridges. These are the very same thing that you're looking at on the screen right now. The screen, of course, is just magnified. So these friction ridges are found on gripping surfaces of the hands and the feet. So you do have friction ridges on both your hands and your feet. The friction ridges are not only on your fingertips, but they're also on your palms and on your feet as well, any surface that's used for gripping. And the idea of these, their function in the human being, is to increase the friction force between the gripping surface and the objects. It makes it easier to hold things and to not slip. These ridges form during fetal development, which means that when a person is born, they already have all these friction ridge patterns set, and these friction ridge patterns, very important, do not change over the course of a person's life. So when you are born, you have a set of friction ridge patterns on your feet and on your hands, and you will have those for life. These friction ridges regenerate if they're damaged. Some of you may have sustained some damage to your fingers or your hands, cuts, scrapes, things like that, and you may have been surprised to see that the ridges and the patterns grow back exactly the way they were before. It is possible to damage the ridges and remove them if you were to damage a layer of tissue called the dermal papillae, which is under the outer layer of epidermis. Then you can stop this regeneration. Fingerprints are apparently unique. That is to say, in the about 150 years of using fingerprints, we have never seen two perfectly matching fingerprints. It may be that this will happen eventually, but they are unique enough that we can use them very confidently as a marker of personal identity. Meaning if I find a certain fingerprint and it exactly matches yours, I know you put that fingerprint there. Here's a cross-section of the tissue on the skin surface. You can see the topmost layer, which has been peeled back, contains the friction ridges. You can see the pores, that is the holes in the friction ridges, and these pores will secrete a little bit of perspiration, sweat, and that's one of the substances that the fingers deposit on the surface when they push upon it. Now you can see underneath the peeled back layer those dermal papillae, these little finger-like protrusions, and this is the layer that actually determines the friction ridges above. So if you can damage the dermal papillae, or if you have some abnormality in this layer, then you may be able to remove or alter the friction ridges. So what types of fingerprints are used in criminology? What do we see at the crime scene? We have visible prints. These are fingerprints that are deposited in some colored material on a surface. So you get blood on your fingers, ink, chocolate, any colored material, and you touch the surface and you leave a visible mark behind. We have plastic fingerprints. These are made by impressions of the finger ridges upon a malleable surface like clay. I saw a case once where actually it was a heel print was left in a hot dog roll, and this is actually what led to the person's conviction. And then we have latent prints as well. So latent prints are when the friction ridges of the finger deposit an invisible layer of either perspiration, which is what's naturally secreted by the fingertips, or maybe a person has put their hand through their hair and they've gotten some of that oil from the hair on their fingers and have deposited those oils on the surface. And these are invisible, but they can be recovered through fingerprint dusting, and there are also chemical reactions which will allow you to develop latent fingerprints. So here is a nice visible fingerprint in what appears to be blood. You can see the friction ridge patterns very clearly there. Here's a plastic print in what appears to be some sort of clay or plaster. And here's a latent print which has been developed with the assistance of a black fingerprint dusting powder. So what's the origin of fingerprints in the field of forensic science? When did we start using this as a means of identifying people? So let's give you a brief history. Prior to the advent of fingerprints, we had a system called anthropometry. Anthropometry basically means human measuring. So what was done is very precise measurements were taken of various bodily dimensions. So for example, we might measure the distance between my wrist and the tip of my pinky, or the distance between my wrist and my elbow, the distance from my tops of my ears around my forehead to the other ear. And we would record these measurements taken as precisely as possible and use that as a means of identifying people. So if somebody else comes in and we're not sure who they are, we might take those measurements, check it against our books, and see if there's anybody who matches those dimensions. So this was used for really not all that long, 20 years or so. And in the United States, there was a case that made folks feel that anthropometry was maybe not a great system. And that was that a man was brought to be imprisoned at Leavenworth Penitentiary in Kansas, and they found that he was already there. So there was a man already there who was named William West, as was the person who was brought there. They looked fairly similar. So here are the two men. Certainly not identical, but there's a similarity. And what's even more surprising is that their bodily dimensions were perfect matches for each other. According to the precision with which these two men could be measured, this system of measurement could not distinguish them. So this was a clear sign that this method of identifying people just really wasn't that good. If there are multiple people with the same measurements, then you can't use that as a personal system of measurement. So what can we use? We can use fingerprints, and William West and William West, in fact, do have different fingerprints, and this is how they were eventually distinguished. So Francis Galton was the one who popularized fingerprinting. This was in the 1890s, but the use of fingerprinting didn't really take off in the US until a bit later in 1904, after this case of William West and William West, and after actually Scotland Yard came to the US and did some demonstrations for police agencies here, showing that fingerprinting was pretty good and it worked well. Since then, this has been an extremely common and popular tool in forensic science, and we've developed databases here, in particular systems that are called automated fingerprint identification systems, and these were first launched in the 1970s. So let's talk a little bit about those systems. So we abbreviate these as AFIS. You may have heard of this before. There are many AFIS systems, and in all of these systems, computers are used to scan and encode fingerprints for high-speed processing. So there's like a little glass plate with a scanner underneath, and you put your fingers on the little glass plate, scans them, digitizes them, and figures out all the different marks on the fingerprints and encodes that in some file, which is then accessible to anybody who shares access to that system. So in contrast to a human fingerprint analyst who could maybe make a comparison, several comparisons per hour, an AFIS system can make thousands of comparisons per second. So you can see the clear advantage to using such a system. And the output is a list of candidate matches. So if you take some fingerprints from somebody and you put them into the system, you'll get a set of possible matches. And then what do you do with the possible matches? Those are checked personally by a trained fingerprint expert. So the ultimate determination is made by a human fingerprint analyst. There are a bunch of different AFIS systems, some at the local level, county level, state level, as well as federal level. And unfortunately, not all of them are compatible with one another. There's different software systems that manage these AFIS databases, and they don't all actually communicate with each other. So there is currently no complete system that takes all of the fingerprints that have ever been taken in the US or in the world and collects them all together. The largest one is in the FBI, and that is the IAFIS, or the Integrated Automated Fingerprint Identification System. And they have over 100 million fingerprints stored there. So we have AFIS systems for doing these comparisons, but how are fingerprints analyzed and compared? So the system we use is called ACE-V, and ACE-V is a 4-step process to identify and individualize a fingerprint. The first step is analysis. This falls into two subdivided processes. First is the primary pattern classification. So this is looking at the very general pattern that we can see in the fingerprint. Those are loops, whorls, and arches. After we've done that, we analyze the ridge characteristics, also called minutiae. These are things like ridge bifurcations and ridge endings, and we'll talk about this in more detail momentarily. Then we do a comparison. So we compare the question fingerprint to the candidate fingerprint. The fingerprint that we found at the crime scene, for example, to the fingerprint that we've taken from the suspect. Then we do an evaluation. We say, is this a match, or is this not a match? And then finally we call in a second examiner to take a look at the fingerprints and see whether they agree with us that it is a match or it is not a match. So we have a second person to verify our findings and confirm that we've done our work correctly. That's the ACE-V system. So we said in the analysis that we do a primary pattern classification, then we look at the ridge characteristics. Let's take a look at that primary pattern classification first. So what are the 3 general ridge patterns of fingerprints? How do we distinguish them? First of all, we have loops. So this is a nice example of a loop type fingerprint. And what I hope you can see here is that we have a central core, which has been labeled, and the lines circle around it. They enter at the lower right part of the image, they circle around this core, and then they exit at the lower right part of this image. Let me say that again, and really try to follow along with your eyes. These lines enter the picture at the lower right of the image, they circle this core, and then they exit at the lower right of the image. Now, on the left side of the image, you'll see another characteristic of loops, which is a delta. So you can see that on the lower left, you have a set of lines coming in that diverge, and then these lines go around that core structure. And we call this divergence a delta. So all loops will have exactly one delta. And these lines that then go around the core, we call type lines. So this is one of the first patterns. This is the loop. We also have whorls. Here's a whorl. So in contrast to loops, which have only a single delta, here I think you will be able to recognize not one, but 2 deltas. So you'll see on the lower left area, middle lower left, 1 delta, and then you'll see that core in the middle swirling around, and then you'll see another delta on the right side of the image. And these 2 deltas, that's characteristic of a whorl pattern. And there are a couple different types of whorls. This one that you're looking at right now is a plain whorl, but that's what we'll stick to for now, and we can elaborate on this later if we need to. Finally, we have arches, and there's 2 types of arches. Figured I'd show you both because they're pretty simple. An arch is just basically a little bit of a wave in the ridge patterns. We have a plain arch, which is more of a gentle arc, and then we have a tented arch, and the tented arch is just more of a sharp pattern, less than a 90-degree angle, if you like. So that there's a 90-degree angle, tented arch would be somewhat less than that. So those are the 3 types of general patterns. We have loops with single delta, whorls with 2 deltas on either side and the whorl in the middle, and we have arches, which are just sort of waves, either pointy ones, which are tented, or smoother ones, which are plain. So once we've analyzed every fingerprint that we've taken from somebody in terms of whether it's a whorl or a loop or an arch, we can do what's called a Henry primary classification. And this is just an initial way to look at the fingerprints. It's not final. So what happens is we give each set of fingerprints a number based on the number of whorls in the fingerprints. We could have done it based on loops or arches or whatever, but we just picked one of the patterns. And so if you have 3 out of 10 of your fingers are whorls, and those whorls are on your right thumb and your left index finger and your left pinky, then you'll have one number. And if somebody else has 3 whorls as well, but they're on different fingers, then they'll get a different number. Another person has 7 whorls, they'll get a different number. So there's a different number given to each possible combination of whorls or no whorls. And so that's a unique number for each of those. So what we do is we take this primary classification that just tells you basically how many fingers have whorls and which fingers are they, and then you can check that against the database, and then you can exclude anyone who doesn't have those general patterns. Because we know that if I have a whorl on my left middle finger, and the person you're checking me against doesn't, then you don't need to go any further. You know that person isn't me. So this is just like a first sort of rough estimate. This is easy to do. Even pre-computer, you can do this pretty fast. It reduces the load today on databases, so you can sort through things more quickly. And so what you end up with is the results from such a comparison would be a bunch of matches that have the same general pattern on every finger. So all of the matches that are returned, if your suspect that you've brought in and fingerprinted and submitted to the system has a whorl on his left thumb, then all the returned patterns will have a whorl on the left thumb. If your suspect does not have a whorl on the right finger, then all of the matches returned will not have a whorl on the right finger, and so forth. Now, this is not enough for a match. This is absolutely not enough for a match, but it is enough to exclude a number of possibilities. In order to have a match, we have to look at the ridge characteristics. So let's take a look at that now. What are the details of fingerprints that can be used to identify a person definitively? These general patterns are useful, but they're not enough to definitively identify somebody. So, ridge characteristics, let's take a look. The final identification of a person is based on the ridge characteristics, which we can also call minutia. Either term is fine, they're both commonly used. What are the types of ridge characteristics we look at? We have bifurcations, this is where a ridge splits in two. We have ridge endings, this is where a ridge, ends. We have enclosures, this is when a ridge splits and then rejoins, looks like this. And we have ridge islands. These are very short, isolated ridges. Sometimes they look like dots, sometimes we just call them short ridges because they appear and then they stop right away. Most APHIS systems focus on bifurcations and ridge endings, I think just because they're the easiest to discern. So let's take a look. So here you can see in this image a number of ridge endings, bifurcations, and enclosures. So let's take a look from the labels that start on the left side and work our way around clockwise. So you'll see on the left side it says ridge endings, and you can see the arrows point to some places where indeed some ridges have ended. So there's some ridge endings. Then we continue in a clockwise fashion, we can see a first bifurcation. So there you can see that a friction ridge is coming from the lower right, and it's coming up, and then when it hits the area where the arrow is pointing, you can see the friction ridge splits into 2 ridges. There's your bifurcation. Continuing clockwise, we see another ridge ending, which is just the ending of a ridge. Continuing clockwise, we can see an enclosure. This is basically a bifurcation followed by a coming back together, a unification of these ridges. Continuing on clockwise, we can see a ridge island or a ridge dot. This is just a single very short ridge. And then at the bottom there, we can see another bifurcation where the friction ridge splits. So what I've done here is I've taken 2 fingerprints and marked with red dots each of these ridge characteristics. And there are many more ridge characteristics in these images, but we only need a certain number of them. So I thought I would just focus on those ones there. So you can see number 1, these are the same fingerprint, by the way. The one on the left is an inked fingerprint that was taken at the police station. The one on the right is a latent fingerprint. This was dusted and picked up. You can see, by the way, that the latent fingerprint is pretty low quality compared to the inked one. So there's some difficulty there. So you can see the first one, labeled in number 1, that's a bifurcation. You can see that. Number 2 is a ridge ending. Number 3 marks out an enclosure. Number 4 marks out a ridge ending. Number 5 is a bifurcation. Number 6, 7, also bifurcations. 8 is a ridge ending, 9 is a ridge ending, 10 is a short ridge, 11 is a bifurcation, and 12 is a ridge ending. Now might be a good time to pause the video and make sure that you can see each of these items in, I would say the leftmost fingerprint would be the place to focus because this is the easiest one to see. So go ahead and pause the video and just make sure that you actually can see the bifurcation wherever there's a bifurcation, that you can see the ridge ending wherever there's a ridge ending. This takes a little bit of practice, so please pause the video for a moment or two and see if you can find all these things and see them for what they are. Are you back? Did you do it? I hope you did it. If you didn't, go do it now. But if you did, let's keep going. So on the right side of the screen, you can see the latent print, which was pulled from the crime scene. And you can see that all of these 12 characteristics, bifurcations, ridge endings, enclosures, short ridges, are present in that one there on the right. Now, it's a little harder to see them, but they are there. And one of the things that I'd like to draw your attention to, the reason that I added these red dots, is so that you can verify that not only are all of these characteristics present, but they're present in the same pattern. So if you look at the pattern, sort of try and ignore the fingerprint underneath, and just look at the pattern of the red dots on the left. Now look at the pattern of the red dots on the right. If I did my job correctly and I put the red dots in the equivalent places, then you'll see that the pattern is exactly the same. There's no difference in the pattern. The angles are the same, the relative distances between the dots are the same, and this is what we must have to have a definitive match of two fingerprints. And indeed, what we have here is 12 ridge characteristics in exactly the same places, exactly the same relative to one another. This is a match. So whoever this leftmost fingerprint belongs to, that person left this fingerprint on the right at the crime scene. It doesn't mean they did the crime. It just means that their fingerprint was there. So, I want to tell you a brief story about the Madrid train bombings and a man named Brendan Mayfield. On March 11th, 2004, bombs exploded at 4 train stations in Madrid, Spain. These killed 192 people and injured over 2,000. Partial fingerprints on a bomb fragment were recovered, and they were submitted to the FBI's AFIS system, and this led to 20 possible matches, including Brandon Mayfield of Portland, Oregon. The FBI described the match to Mayfield as 100% verified. Mayfield then was subject to warrantless wiretapping and surveillance under the USA Patriot Act, and so they tapped his phones and they surveilled him and his family. A warrant was not issued by a judge because this was a terrorism case. The government had recently given itself the authority to do these sorts of things without a warrant. Normally you need a warrant to collect this sort of evidence, but that is no longer the case. The Spanish government reported to the FBI that Mayfield's prints were not a match to the bomb fragment print. However, Mayfield was arrested by the FBI and held without access to legal counsel or to family. So again, you know how when a person gets arrested, they have a legal right to have a lawyer present or to make phone calls to their family, things like that. This was not the case for Mayfield, again, because he was being arrested under suspicion of terrorism. Special rules apply there. The Spanish government announced a match to an Algerian, and the FBI released Mayfield. So 2 years later, the U.S. government admitted their wrongdoing and they paid $2 million to Mayfield. And I'd like to show you the fingerprints that they used in making their 100% verified assessment. So this is Brendan Mayfield's actual inked fingerprint on the right, and on the left is the latent print which was recovered from a bomb fragment at one of the Madrid train bombings. And what I'd like you to see is just that the quality of the latent print on the left is rather low. You can see ridge detail, but there's also a lot of blurring here. There are whole areas that are basically totally missing, that are all white and washed out, and there are whole areas that are just soaked in blackness and that you can't really identify. And so they may have found a few ridge characteristics that matched, but it would have been really tough to make a definitive comparison here. So it's not to say that you couldn't make a comparison with such an image, but the FBI's claim that this was a 100% verified link, I think was a claim that was more in service to their desire to have a suspect in hand than a truthful statement of the reliability of this conclusion. In fact, the conclusion I want to impress on you from this case of Brendan Mayfield is this: all forensic techniques are subject to error. These are possibly human error of people who make mistakes in assessing them. These could be that the evidence collected is of poor quality or contaminated, but there is just no single technique which is absolutely perfect and foolproof. Every single forensic technique should be treated in a criminal or civil case with skepticism and assessed within a certain window of confidence. We should assess it in terms of how confident we can be in it, not assume that it's perfect. So, today we discussed a number of things. We saw that fingerprints result from the impression of friction ridges on the skin of the hands or feet onto a surface. We saw that fingerprints recovered from a crime scene may be visible, plastic, or latent. We saw that in the US, fingerprints saw widespread adoption begin in the first decade of the 1900s. We saw that analysis and comparison of fingerprints involves first a primary classification, according to general pattern, then a finer analysis of ridge characteristics, and we saw, finally, that fingerprinting, like all forensic techniques, is subject to error. So, there is your introduction to fingerprinting. If you have questions, we'll take a look at them together. I hope this was helpful. See you soon.